October 6, 2022, I will be able to find the constant of proportionality and interpret it in context when given a graph. Homework, Unit 2, Lesson 11, cool down, practice optional. Grade correct and submit.
Okay, let's pick a cheer to do for your Roxy. Indiana Jones, we won't see it, but we can hear it. Ready, go. Da 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 da. Great job. Hello, my name is Kathy Dixon. Welcome to the Math Reflective. I've had a lot of requests for seeing a lesson in action, so today I'm going to give it a try to record an entire lesson and hopefully be able to give you an idea of how I use Open Up Resources 6-8 Math in my classroom. Before we get started, yes, today we are doing Lesson 11, as Roxy said. We're starting to look at how we can see proportional relationships in a graph. We've already known how to use a table to find the y/x quotient. We know how to look at an equation to think about and reason about proportionality. But yesterday we began to look at what that looks like in a graph. Who can recap that? What do we have to see on a graph to know that something is proportional? Raise your hand. What do we want to see? Nicholas?
You want to see that the line goes through the origin.
The line goes through the origin, yes. Something else that we want to see, Kai? It goes in a straight line. So it has to be a straight line that passes through, goes through. Some students say starts at the origin. If the x has a 0 value, that makes sense. The y would have to have a 0 value, that makes sense. Yesterday's example was the t-shirt. If I buy no t-shirts, 0 t-shirts, I've spent $0. Okay, we're going to continue that conversation with lesson 11 and remind you of our target that we just talked about. You're going to be able to find the COP on the graph, and you should be able to explain what it means in a given situation. So that's our target that we're going to be focusing on. Okay, first you're going to look at this graph that I have on the screen that you have on your iPad. It represents a proportional relationship. Do you notice there's already a point labeled on the graph? What is that point? Raise your hand. Yes? 16, 12, remembering that x comes before y, and we put parentheses around our ordered pairs. I'm going to give you 30 seconds to think about what could our y and x axes say? What could be the titles of these? What two things could we compare where it would make sense to have a 16, 12 coordinate? I want to give you 30 seconds to think about it, and then we're going to collect some ideas from the class. Again, you're thinking of what two things could be in a proportional relationship and that would include 16, 12. You're going to create and think of two things that we can compare. We're not graphing anything yet except for that one point. Yes? We're not doing any calculating yet. Can you hold your question for a couple minutes because it's important to me? Who has an idea? Let's collect some of these ideas. Who has an idea of two things that we could compare? Rory?
The cost and the pencils.
Cost and number of pencils? Okay. That's a good one. Who has another idea of two things that we could compare? Jules?
Pumpkins and money.
Pumpkins? No. And cost again? What else?
You could have 12 penny socks for $16.
Socks and cost? Yes, Stella, thank you. Tiernan?
This number of leaves and bags.
Okay, let me just ask you if this makes sense, Tiernan, because I think you just wanted to have an idea, which is great. I love your contribution. Would 16 leaves and 12 bags make sense? Or 16 bags and 12 leaves? I'm sorry, I'm not laughing at you at all. I'm just picturing.
I know.
I'm picturing all these bags. And like there's a half a leaf and then
You got caught in 4K.
Yeah, that'd be extreme.
You got caught in 4K by a pin.
Well, at least I made you guys happy.
We can edit this part out.
No, keep it in, keep it in.
Okay, okay.
You got caught in everything.
Okay, Sophia.
16 yellow to 12 red.
Okay,
16.
Red
16,
what?
16.
number of red what?
red paint to.
Paint cans?
Sure.
Number of red paint cans to number of, did you say yellow?
Yeah.
Yellow. Okay, those are our choices. We need to pick one. I'm going to call on Mahir. We're not picking 12 leaves and 16 bags, though, right?
Oh, yeah.
Okay. Mahir, pick one of the other ones. Tiernan gets the creative award today, but go ahead, Mahir.
Red paint and yellow paint?
Okay, so we're doing cans of red paint, 2 cans of yellow paint. Which one do you want to be the X?
Red paint.
Okay, red is X and yellow is Y. How appropriate. Okay, your job right now, this is just a warm-up, remember. This is just getting us into the math today. Label the X-axis and label the Y-axis. I meant axis. And then explain what 16, 12 means in this situation. So just go in the order here. We already invented the situation. Go ahead and start number 2, number 3, and number 4. Labeling the axis. Yeah. Oh, the axis is like, this is the x-axis, and then this is the y, so you're labeling. What is this going to represent? Red, what did we say? Number of cans of red paint. Okay, so maybe some of you didn't have as much experience labeling graphs in elementary, and that's okay. So right here, you would write number of red paint cans. You're just labeling that axis. Just like that, number of red paint cans. And usually when we label the Y, we do it on the side here. Number of yellow paint cans. So part of your 7th grade knowledge will be to include that you can give a graph a title, you can label the axes, and you can interpret a point. Jake, what should we title this graph? Like the whole graph, not the axes, but what should we title the graph? What is it about?
Yellow paint to red paint.
Okay, we could call it yellow and red paint. Go ahead and put a title there. I know I'm writing over. What else could we call it? Tiernan?
I thought of something snazzy like paint can problem.
Paint can problem, painting a room.
Paint-a-palooza.
Paint-a-palooza, okay.
Yay.
All right, we're going to be moving on. Last thing, 1612, what does that represent in this situation that Sophia gave us? Whitney,
That there is 16 red paint and 12 yellow paint.
there are 16 red paint cans, 2, remember because it's a ratio, so we're comparing to 12 yellow paint cans. So at this point, get it? I'm sorry, at this point, do you get it? I'll be here all week. Okay, so at this point though, you should be able to look at an ordered pair and say describe what the X and Y mean in the situation. Can you do that? Because we need that going forward into our next part. There are 16 red paint cans to 12 yellow paint cans. Okay, I'm excited about our next activity. I don't know why, but it's one of my favorite activities in Unit 2, and it's called Tyler's Walk. Who's been to an amusement park? Who's been to an amusement park? Yes. Depending on how big it is, it can be a long walk to get to the rides that you want to go on, can't it? Okay, hands down.
Is Gordon America/Six?
That's an amusement park. Yeah. Okay, so Tyler was at an amusement park, and he's walking at a steady pace. He's going from the ticket booth to the bumper cars. So maybe you want to start out thinking about this box could be the ticket booth. He's on a journey and he's trying to get to the bumper cars. I'm going to label that BC, bumper cars. I'm just very visual, so I like to think about he's taking his path here to get to where he wants to go. If you look, number 1, TB is the ticket booth. I'm just taking it right there from the problem. I'm going to star all the parts that you're going to do. The first thing that you're going to do is you're going to explain what this ordered pair, this coordinate means. Now notice, our X is already labeled and our Y is already labeled. So use those labels to help you interpret what 40, 50 means in a situation. You're going to answer that first. Then I want you to go to number 2, complete the table and plot. So complete the table and plot those pairs. This time I do want you to include parentheses. So you're going to complete the table, plot, and then you're going to go on to answer 3, 4, and 5. So essentially you're really doing the whole activity, but I'm going to give you about 5 minutes of quiet time to just think about it yourself. And then we're going to go screen to screen at our tables, and I'm going to be coming around just to watch you work a little bit and capturing your thinking. Who can restate what we're doing? Kai.
First maybe you're gonna explain the coordinates and the coordinates of the building.
Yep, first we're going to explain this coordinate. Then what are we going to do next?
Then we're just gonna
Complete the table and plot the pairs on the graph. Okay, we'll go from there. Go ahead and begin.
How did you get that value there at the bottom?
1.25.
Yeah, how'd you get that?
Because 25 divided by 20 is 1.25.
Okay, did you use a calculator or you knew that in your head?
I know in my head.
All right, can you show the math somehow, how you did that? Like maybe, can you show that y over x column and show that you did that division for that one problem, please?
Okay.
Good job. Can you tell me what you're doing here? I saw you put 40
Yeah.
divided by 50 in the calculator.
So.
Can you tell me which one is x and which one is y here?
So the elapsed time / seconds is 40 seconds.
So that's x or y?
That's x.
Okay, so why don't you label it here to keep
Right.
your information organized? Okay,
Right.
so when you're doing 40 divided by 50, you're doing x divided by y. Is that what
Right.
you wanted to do? Okay.
Right. And then if so that's how you figure out.
So I see you revising your thinking. What happened?
So I realized I need to do y over x.
Oh, okay, y over x, not x over y. I mean, x over y tells us something different. It would tell us the other unit rate. You're trying to find about the distance in 1 second.
Right.
So the x over y would be important to a different question. But good job on revising your thinking. Can you tell me about what you're doing right here on the graph right now? What are you doing?
For number 4, it says how far away was Tyler from the ticket booth after 1 second. And I did the math over here.
Tell me about your math over here.
So I figured out that 20 divided by 2 equals 10 because you need to get 1. And then 25 divided by 2 equals 12.5.
What do you mean 20 divided by 2 is 10? Quiet on the set. Can you show me this again?
Okay, all right, stop. Coming back together in 3. We're back together in 2. And we're whole group in 1. This is what I'd like you to do. We're stopping quiet think time. I want you to do screen to screen at your table. So if you're a table of 3, do you mind if I grab this? Hold on. We're going to do 3 screens like this. And then everybody's going to come around and kind of hover around here, and you're going to talk through these problems one at a time. Go ahead.
Had arrived at the bumper cars.
Can you repeat that? What did it say?
After 40 seconds, he had arrived at the bumper cars.
Does everyone agree?
Yeah, I do. Hang on, let me delete this.
Meters. Could you repeat that?
in 40 seconds he has walked 50 meters.
Do you agree?
Yeah, but I put he is 50 meters from the ticket booth and 40 seconds away.
Are those saying the same thing, but a little bit different?
Yeah.
Yep, that's great.
How long it would take.
Okay, say it again.
What the distance is from the booth and how long it would take.
Okay, in your explanation, Clara, did you say something differently for number 1? What did you say?
Yeah, I got that wrong, but hang on, you can't.
Can you say what you said?
Yeah. I put in 40 seconds. Tyler is 50 meters from the ticket booth.
Okay, so Clara's was a little bit different. She said in 40 seconds he was 50 meters from the ticket booth. You notice how she talks about the values of 40 and 50 in hers? So what do you think we were looking for if you're interpreting the point 40, 50? What do you think you're supposed to talk about?
How far he was away from
Yeah,
the booth.
let's talk specifically. So what could you add to yours to make it a little bit more concise?
I can say about the 40 seconds and the 50 meters.
Yeah, go ahead and add that.
After 40 seconds, Tyler walked 55 meters.
So what does 0, 0 mean in this situation?
I wrote 0 seconds to 0 meters to the ticket booth.
It takes 0 seconds to 0 meters to the ticket booth.
Yeah.
I don't know. I think I was trying to write something. So, yeah, we all got the same answers. 0 seconds.
I didn't see that personally.
Oh, the graph? So for
Now
the
I
graph,
fixed it.
So for the graph, I knew that the seconds would obviously be the x, or no, it would be the x on in the distance or in the meters would be y. So I put my 0, 0, 0 over here, and
I'm so mad. I made the simplest mistake. Instead of doing 25 divided by 20, I did 20 divided by 25.
That is not silly. That is a common mistake,
yeah.
and I've seen students do that in each of my classes today. So that's a different question. So when you're doing x divided by y, it's telling you how many meters, it's telling you how many seconds per meter instead. It's the other unit rate. It's not silly, it's just the answer to a different question.
Yeah.
Show me what you got. What are you talking about?
So we knew that takes 40 seconds to walk 50 meters.
To the ticket booth.
Okay.
And then for our table, we did so our COP was 1.25.
How did you get 1.25?
I took 20.
Let Sophia talk.
We did 50 divided. I did 50 divided by 20, and we got it.
1.25, okay? And then what are you showing here?
I'm mistaken.
What are you showing here?
Oh, well, since 40 times 1.25 is 50, and this is a proportional relationship, then 1 times 1.25 is
1.25, excellent. Okay, let's start with the first question. What does the point 40-50 tell us about the situation?
it tells us that Tyler has walked 40 seconds to the and 50 meters to the booth.
Okay, so Tyler walked 40 seconds and 50 meters to, well, he's leaving the booth. Where is he going to?
Oh,
The bumper cars. Okay, stay there for a moment. Who has another way to say that, but different? You're saying the same thing, but you said it differently.
before we do that, I just want to let you know, think about the ticket booth. I'll draw a TB, that's the ticket booth, and we're going to the BC, the bumper cars, okay? So think about at 40 seconds where he's at. Can somebody say it a different way? Dean?
It took Tyler 40 seconds to walk 50 meters, which is where the bumper cars are at.
Okay, it took Tyler 40 seconds to walk 50 meters. Okay, anything that's similar to that is okay, just as long as you know he's 50 meters from the ticket booth. Okay, because that's where he started. All right, let's do a 1, 2, 3 clap for Ella. 1, 2, 3. Okay, number 2 says plot the pairs of values on the grid. Could somebody come up here and show us where each of those go, and I'll be the scribe and put that down? Sophie.
So, for 20 seconds and 25 meters, you would put it here.
Very good. 20 seconds, 25 meters, so that's 20, 25. Next. You can use that purple power pointer if you want.
So 30 by 37.5 is somewhere around here.
About there?
Yeah.
So that's 30, comma, 37.5. Very good. We've got our 40, 50, and we need for 1. Okay, let's do 1, 2, 3 for her. We'll call somebody up to help us with that. 1, 2, 3. Okay, somebody else help us. How did we complete this row? How do we complete this one row using what we've already learned earlier lessons? Dennis.
You know that the seconds are being multiplied by 1.25.
Okay, you said the seconds are being multiplied by 1.25. How did you get that?
I did 25 divided by 20.
Okay, so you did the y over x quotient. So you did 25 divided by 20 on your calculator to get 1.25. What do we call that number?
The constant of proportionality.
It's the constant of proportionality, right? Often I highlight it yellow in the table. What is another name for that?
A proportional relationship.
It's a proportional relationship.
COP.
It's the COP. What else?
The K factor.
The K. What else? Unit rate. Okay, so we know that going across, we can multiply each one by 1.25. So go ahead and complete and talk about that one row, Dennis.
Okay, so
You said we multiply by 1.25.
so this would be 1.25.
Okay, what does this point mean? What does it mean?
It means that for every second he walks, he walked 1.25 meters.
Yeah, for every second he walks, he gets 1.25 meters further. Let's do a 1, 2, 3 clap for him. 1, 2, 3. Okay, now we need to figure out where to plot that for this. I'm going to go ahead and do that. If this is 5, right, it's going to be right here, and this is 5. I'm going to say it's about right here, maybe? Okay, so we've got at 1 second, he's at 1.25 meters, making sure you're not confusing your x and y coordinates. The x goes first. So there's our point there. Could we draw a line through this, these points, and would it be a straight line? Yes. And then I show that it's continuing with my arrow. Does it go through the origin?
Yes.
We already know, is it proportional?
Yes.
Yeah, because it has that constant unit rate every time you multiply across the row to get the distance. And yesterday we talked about discrete and continuous. Could we measure like at 10.5 seconds, could we see his distance?
Yes.
So we would want to connect that line. It's a continuous graph. Let's jump down to number 3. What does 0, 0 mean in this situation? Cam?
It stands for the origin.
Yep, it's the origin. What does it mean about the bumper cars in Tyler's walk?
That he traveled 0 seconds.
So at 0 seconds,
He traveled 0 meters.
he walked or traveled, 0 meters. Let's do a 1, 2, 3 clap for Cam. 1, 2, 3. Thanks for your contribution. So it's really important, one second, it's really important that when it says in this situation, I mean in this context, what does that 0, 0 mean? Yes, what's your other one?
It can also mean the location of the ticket booth because that's where he kind of technically started.
Okay. So it can also represent his starting point. Absolutely. Great addition to the conversation. Let's celebrate Richard. 1, 2, 3. Awesome. It is his starting point. You're absolutely correct. How far is he at 1 second? We should be able to interpret that now from everything we talked about. Caleb?
1.25.
He's at 1.25 meters. And this shows this with this 1 and 1.25 coordinate that we put down. What is the COP for this relationship between time and distance? What is it?
1.25.
And remember, I want to reiterate, because some people had a hard time with that on our last assessment, we're talking about a ratio. That y over x quotient is a ratio. We're comparing distance, so this would be meters, per 1 second. So yes, the COP is 1.25, but it represents a ratio. So I want you to always remember that. Even though we're communicating that it's 1.25, it does represent that unit rate. How much of something for 1 of something else. Okay, we're going to move on to seagulls eat what?
Whoa.
4 seagulls ate 10 pounds of garbage. 4 seagulls are eating 10 pounds of garbage. Assume the information describes a proportional relationship, okay? You're going to plot a point that shows the number of seagulls and the amount of garbage they ate. You're going to draw a line through that point in 0, 0. And then it says to plot 1K on the line. What does K represent again?
The COP.
The COP. And you have to be able to interpret what that COP means in this context. Okay, let's see what we have here.
2.5.
Don't say anything out loud, please. Remember, you're using this information. Quiet think time first. 4 seagulls eating 10 pounds of garbage. If you need to plot or make a quick T-chart for yourself, you could. Or you can just start plotting these on the graph. Go ahead and read the directions. Quiet think time first. Okay, let's wrap this up. Who can come up and help us synthesize? There's our synthesis bell. Who's going to help us synthesize? Come on up, Cam. Okay, so first it said to plot the point that shows the number of seagulls and amount of garbage. Where would I plot 410?
Right here.
Okay, that's 410. And then it said to draw a line through 0, 0.
Yeah.
Let me do that real quick. Okay, always go through your graph and do an arrow. Then it asks us to plot the point 1K. Can you move over to that where that T-chart is there? All right, tell us how you figured this out.
Well, I divided 10 by 4 and I got 2.5.
Okay.
So I did 1 times 2.5 and I got 2.5.
Let me move this over. You did 10 divided by 4, which is our y divided by our x, and it equals 2.5. So you got 1 and 2.5. Can you tell us where that would go on this
I
graph?
put that right there.
Right here?
Yeah.
And do you see where my line crosses there as well? If you drew it correctly, it should be at the same spot. 1, 2.5. And remember, that is our K. Please label that. You could even highlight, we always like to highlight the COP. That's going to be the number that we're multiplying in our T-chart across the table. Multiplying by X to get Y. Cam, can you close this out by telling us what does this mean in the situation of the seagulls? What does it mean?
That means 1 seagull ate 2.5 pounds of garbage.
Every seagull or 1 seagull eats 2.5 pounds of garbage. I'm just going to put a P there. It could be LB as well. Wow. Is there anything else that we needed to answer here? Okay, let's do a 1, 2, 3 clap for Camden. 1, 2, 3. Okay, just for our final synthesis, I want to take us back to our learning target. Can you find the COP in a situation, and can you interpret it in context in a graph? So you should be able to, given one set of values, Draw a line to show that graph, and you should be able to interpret in context. Please don't close your iPads yet if we're still synthesizing the lesson. You should be able to interpret what the y and the x coordinates mean. And finally, where do we see the COP on a graph? Where do we see the COP on a graph? When x is 1. That's where we find the COP. Okay, push in your chairs, collect your belongings, and have a great day.